Well, hello everybody, and welcome to Chapter 2 lecture. I hope the first chapter was helpful, and if it was really easy, well then that's even better. And if it wasn't as easy and if you have some questions, I need to hear from you. I haven't heard from you yet, so if you're having a bit of a hard time with anything, please let me know. Math is one of those things where you have to know Phase 1 before you can go to Phase 2, Phase 3, and Phase 4. So just like building a house, you're not going to put in your plumbing until your foundation is really set, right? That's just going too far ahead. And we cover a lot of material really quickly, so don't think you're going to call me in a day or two or call me next week or you'll catch up next week. Boom, 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 boom. Assignments are due. So, other than that, let's move forward with fractions. This is, a lot of people freak out when they hear fractions because they have no idea. Calm down, we'll take it one step at a time. Before we do that, I just wanted to bring up a quick topic. I need you guys to submit all your homework assignments on My Course Connection. Whether it's in the online text box or if it's uploading any documents or anything, please put it on My Course Connection. I don't want your homework to get lost in my inbox. I have come up with a system, but at the same time, if it slips through, I don't want you to get no credit just because I didn't find it. So it's easy for everything to be kept in one location. Submit it on My Course Connection. It's easy. If it is late, then you'll have to email it to me, and then I'll look at the timestamp of when you emailed it, and I'll take off the late points accordingly. So if you're debating whether to do it at 11:50 or just past midnight, I look at that date. So be sure to send it to me as soon as possible so I don't take off as much. Remember, 10 points for every day that is late. But remember, even if it's 2 days late, 80% is still so much better than nothing at all, right? Your alternative is 0, so don't worry about it. If something happened and you weren't able to get to it, just type it up, send it to me the next day, 2 days, 3 days. Even a C is better than an F, right? So that's it. I will be done with grading all your homework assignments on Wednesday, and hopefully you'll get the feedback that you need for that. And again, if you have any questions about anything at any time, be sure to let me know. Okay, let's start with fractions. Take a deep breath in, take a deep breath out, and let's go. Okay, so what are some types of fractions? Okay, you have proper fractions, improper fractions, and mixed fractions. Let's look at the first one. Okay, right now we're looking at proper fractions. The numerator is the number on top, the denominator is the number at the bottom. We just cover that so that you know, but the world is not going to fall apart if you don't know. It's just easier if you do know that when we talk in the future, and I explain something and I say numerator, it clicks quickly. You don't have to go back. But as for the math, it doesn't really change anything whether you know what the numerator is and what the denominator is. So let's talk about it. A proper fraction, the top number is smaller than the bottom number. The numerator is smaller than the denominator. Now, what is a fraction? Okay, a fraction means it is a part of a whole. We didn't have enough of whatever it is to make a whole, so we have a portion of that. Now, what portion do we have? What fraction do we have? It's used interchangeably, and that's what we call proper fractions, because a proper fraction means, you've heard the word fraction in sentences. It was a fraction of the price I paid at the brand store. I got it, at a fraction of the price I would have paid at the mall. You just mean a portion of that price, a tiny bit of that price. And so it's a proper fraction. It's smaller than 1. Now this is compared to your improper fraction, where your numerator is equal to or greater than your denominator. Now this just means if you have a pizza pie cut into 8 slices and you have 9 slices of pizza, you have a whole plus some, right? So you don't have a fraction of a whole, you have more than a whole. That's why it's not really, you can't say it's a fraction of the pizza, because technically it's the whole pizza plus some. So that's why we call them improper fractions, and those are very common as well. So proper fraction, the top number, the numerator, is smaller than the bottom number, the denominator, and in an improper fraction, the top number is bigger than or equal to the bottom number. If I have 8 slices of pizza, in a pizza that I cut into 8, and if I have all 8 slices, how many pizzas do I have? I have 1 whole, and 1 is not a fraction, right? It's a whole. So the final one is your mixed numbers, okay? And this is the one that we use more when we talk. We don't say, oh, I have 9 slices of pizza. You say, no, I got a pizza and 2 slices extra. Make sense? Maybe you don't say that, but most people, they talk about, I have a whole plus some leftovers, right? So a mixed number is exactly the same. It's a whole number and a fraction in the same number. So we have 5s and 1/6, 5 and 1/6, 5 and 9/10, 8 and 7/8. So basically what that means is I have 5 whole, and then the other one, if we were to cut it in 6, I would have just one of those 6. 5 and 9/10. I have 5 whole, but I don't have quite enough to make the 6th whole. I have 9 pieces out of 10. If I have that 10th piece, I would have 6 wholes. So how do you convert improper fractions to whole or mixed numbers? This is important, okay? Now, you know how I said that, I have 9 slices of pizza? Well, actually 9 is 1 whole pizza plus 1 slice left over. How do you do that when it comes to bigger numbers and if it's not something as easy as pizza? Well, there are 3 steps, okay? Divide the numerator of the improper fraction by the denominator, okay? So basically what this means is the top number divided by the bottom number. 15 divided by 15 is equal to 1. So we changed improper fraction to a whole number, okay? I have 15 slices out of 15 slices. That means I have 1 whole, okay? Anything divided by the same number on the top and the same number at the bottom, that is always going to be 1. But if you have something and it doesn't equal out and it's not 1 exactly, this is how you do it. So what is 16 divided by 5? We went over division on Monday, right? So 16 divided by 5, 5 goes into 16 3 times, because 3 times 5 is 15. So 5 goes into 16 3 times, and then there's 1 left over, right? So the difference between 5 times 3, which is 15, the difference between 15 and 16 is 1. So I have 3 wholes, and then I have 1 piece out of 5 left over. And so they just show you at the bottom how you can do that in your long division, but I just basically went over the concept. But what do you do if you have mixed numbers and you need to convert them to improper fractions? Even though in our daily life we might use mixed fractions, mixed numbers more than improper fractions, sometimes in math we need to convert it so that they're all in improper fractions, and you'll see that as we get along. So how do you do this? Just follow these 3 easy steps every single time and you will be fine. If you understand it and you want to explore and figure out why, that's fine. If you don't understand it, then just go ahead and do it like this and you'll be fine. Okay? Number 1, multiply the denominator of the fraction by the whole number. Denominator down at the bottom. Right, the number at the bottom. So the whole number times the denominator. So 8 times 6, which is 48. Okay? Out the product is the answer to a multiplication sum. And what multiplication sum did we have? 8 times 6. Add that product, 8 times 6, to the numerator of the old fraction. What was the old fraction? 1 over 8. Right? So what's the numerator? The number on top. So 48 plus 1 is equal to 49. And then, third easy step, place the total from step 2 over the denominator, the number at the bottom, of the old fraction. What was the old fraction? 1 over 8. Right? So it's 49 over 8. So 6 and 1/8 is also equal to 49 over 8. Please let me know if you have questions. Okay? So how do you reduce fractions to the lowest terms? Okay? Sometimes you can have 200 out of 1,000, and you're like, whoa, that's a lot of numbers. Well, that's a big number. It is. But at the same time, it can be reduced. 200 over 1,000 is the same as 1 over 5. Now, what's easier to work with? 200 divided by 1,000 or 1 over 5? Right? So that's why we reduce to the lowest terms. So basically, it's a really easy process. All you do is find the lowest whole number the lowest, the smallest whole number that will divide evenly into the numerator and the denominator. So 24 divided by 30. The smallest number that will fit into 24 and 30, right? You can fit 2, but you can't fit 4, and you can fit 6. Okay? If you were to do it as 2, it would be 24 over 30. You would divide the top by 2, divide the bottom by 2. It would be 12 over 15. Now 12 over 15, that's not the lowest it can be. Remember, we want it to be the lowest possible. So 6 is the number that you say 24 divided by 6 and 30 divided by 6, and you get 4 over 5. I think they meant to say find the biggest whole number that will divide equally. That is a mistake on my PowerPoint. But you want to make sure that the final product is the lowest that it can be, 4 over 5. That should be the lowest possible. Okay? But what about finding the greatest common divisor? How do you find that number that we need to divide it? Okay? Number 1, divide the numerator into the denominator. Divide the top number by the bottom number, into the bottom number. So your top number goes on the outside of the bracket, your bottom number goes on the inside of the bracket. You figure it out, you solve it, and you get your answer. Okay? Now, step number 2 is divide the remainder in step 1 to the divisor of step 1. So now, the remainder that we have, I'm sorry, I just got distracted by my cell phone. It's just going off the hook right now. I lost my train of thought. I apologize. Divide the remainder in step 1. What was the remainder? It was 24. I'm sorry. No, it was 6, right? So now we want to divide the remainder into the divisor. What's the divisor? The divisor is the number on the outside. So the remainder is 6, and we want to divide that into 24. Okay? So now 6 into 24 is equal to 4, right? So now step number 3 is divide the remainder of step 2. What's the remainder of step 2? 0 into the divisor of step 2, which is 6. Continue until the remainder is 0. We don't have to do step 3 because we already got the remainder is 0 in step number 1. So now we know that 24 divided by 6 is 4, and 30 divided by 6 is 5. And that is the lowest that we can simplify it to. Okay, now sometimes not sometimes, if you find any of these numbers, you don't have to do this every single time, because you can make sure that you can use these tricks to make it simpler for you, so you don't have to keep doing that old system every single time. So now you know that it's always divided, like these are how do I say this word? Divisibility tests, right? So this just means I want to know, can I divide it by 2? Is it divisible by 2? Is it divisible by 3? Can I divide it by 2? Can I divide it by 3? Can I divide it by 4? Etc., etc. And I'll show you how you can do it. If the last digit is either 2, 4, 6, 8, or 0, it can always be divided by 2. So 12 over 14, you can divide the top by 2, you can divide the bottom by 2, easy. Okay? But how do you know if you can divide it by 3? What if it doesn't end on 2, 4, 6, 8, or 0? Well, now you can add up the numbers on the top and see if the numbers that you've added up, if they're divisible by 3, then you can divide the entire equation by 3. So what does that mean? What do I mean by add up the numbers? So 36, what's 3 plus 6? 9. Is 9 divisible by 3? Yes, because 9 divided by 3 is 3. And then the bottom number, 6 plus 9 is 15. 15, is it divisible by 3? Yes, because 15 divided by 3 is 5. So now you know you can divide the top by 3 and you can divide the bottom by 3, and then you'll get 12 out of 23. Okay, how do you know if it's divisible by 4? Well, this is pretty straightforward. If the last two digits can be divided by 4, then the entire equation can be divided by 4. The reason why I'm bringing this up is sometimes you're going to work with numbers that are in the hundreds or the thousands, or even the millions maybe sometimes. You want to make sure that you're not always, you're not spending too much time. You can use these tricks to save time. So, if it was a 5, okay, if it ends on a 0 or a 5, you can divide it by 5. Remember, these are for the top and the bottom numbers, okay? To see if it's divisible by 6, you have to do the same equation that the same test that you did with the 3, add the digits and all those types of things. But it has to be that the number is even, right? So 15 is not an even number. 15 can divide into 3, so it'll pass the 3 test, but it won't pass the 6 test because you can only do the 6 test if it's an even number. What's an even number? 0, 2, 4, 6, 8, anything that ends in those numbers, it's an even number. Okay? And then of course, is it divisible by 10? If the last digit is just plain old 0, it will be divided by, you can easily divide it by 10. We talked about that a little bit, where you just cut off the end of the 0 on the top, cut off the 0 at the bottom, and voila. Okay, so how do you raise fraction to higher terms when the denominator is known? Okay, so this means so if you have 4 out of 7, it's the same as you having 16 out of 28. If you have one slice of pizza, if you have one big old pizza and you cut it into 4, right, and you eat 2 out of the 4, you ate half the pizza, right? But if you cut the very same pizza, if you cut that into 8 pieces and you eat 4, are you going to say, man, I ate 4 slices of pizza, and this one ate 2 slices of pizza. I definitely ate more than them. No, right? Because there's more slices, you have to eat more to get to that same quantity. So that's the same thing. If a slice of pizza was cut into 7, if a pizza was cut into 7, then those 4 that we have, okay, what proportion is that? And if that same size was cut into 28, how many would I need so that it can equal the 4 when we're talking about the 7 slices? Make sense? So number 1, 2 steps. Divide the new denominator by the old denominator to get the common number that raises the fraction to higher terms. New denominator, the new number at the bottom. Old denominator, old number at the bottom. 28 divided by 7, 7 goes into 28 4 times. So we're going to divide the bottom numbers by 4. So obviously the top number, we have to multiply by 4. So 4 times 4 is 16. Okay, now you want to check that. If you say 4 times 4 is 16, 7 times 4 is 28. If it's equal, it means you got it right. Same thing, 16 divided by 4 is 4. 28 divided by 4 is 7. So we got 4 over 7, which means we did it right. Okay, how do you add like fractions? This is where I come in with, you need to have the whole apples and oranges things. You can't add unlike terms. If you're adding 7s, they all have to be 7. If you're adding apples, they all have to be apples. If they're all 8s, they have to be 8s. If they're all oranges, I'm mixing them so that you can see what I'm talking about. So make sure that your bottom numbers are equal. Okay? Then you add your top numbers. So once we have the same thing, once we know are we working with apples, oranges, or peaches, then we can start adding them up. So 1 over 7 plus 4 over 7 is equal to 5 over 7, right? So if I have 1 apple plus 4 apples, I have 5 apples. So it's the same thing. 1 over 7 plus 4 over 7 is equal to 5 over 7. If the total of your numerators is the same as your original denominator, convert your answer to a whole number. Right? So if we were talking about the 7s and we had 7 over 7, remember how I said the top number, if it's equal to the bottom number, it's always equal to 1. So make sure you convert it. If it's larger, if you get an improper fraction by doing this, like 11 over 9, convert it to a mixed number. So what is the least common denominator? That's your LCD. Okay? That just means what is the smallest number that both denominators can fit into as a whole. Okay, so for 3 over 7 plus 5 over 21, the smallest number that both of those can fit into is 21, because 7 can fit into 21, but 21 can only fit into 21. 21 can't fit into 7. It's too big, right? So what's the smallest number that everything can fit into it at least once? So how do you add unlike fractions? Okay, this is really good because this shows you what I was talking about with the apples and the oranges. If you have all these different bottom numbers, how can you make sure that they're all the same so that you can add them up? Because if it's 1 over 3 plus 1 over 8, you know, sure, you're going to add the top 2, which is going to be 2, but if you add the bottom 2, it's going to throw it off and it's going to be a completely different thing. So it's not going to be right. So what it is, you're going to have to find that one number. What's that one number that all 4 of those numbers can fit into? Okay? 3. Is everything going to fit into 3? No. 8 doesn't fit into 3. 9 doesn't fit into 3. 12 doesn't fit into a 3. What about 8? 3 doesn't fit into it directly because 3 times 3 is 9. 3 times 2 is 6. So there's nothing that, you can't multiply it cleanly to get it to fit exact. 9 doesn't fit into 8. 12 doesn't fit into 8. So you have to find the number, and so they found that all of those numbers go into 72, okay? So how do you get from 3 to 72? Well, you multiply it by 24. And if you multiply the bottom by 24, you have to multiply the top by 24. Same thing, how do you go from 8 to 72? You have to multiply it by 9. So if you multiply the bottom by 9, you have to do the same for the top. So you keep doing that until all the bottom numbers are the same, and then you can add the top numbers and get 47 out of 72. I hope this is helpful. Again, if anything is hard, please let me know. I will be more than happy to help you. What is a prime number? A prime number is a whole number greater than 1 that is divisible by itself and by 1. Okay? So this just means, for example, the number 5, it doesn't fit into anything except 1. You're right, you can have 1 fit into 5 times. And you can say 5 divided by 5, which is 1. Right? No other number fits in there. 2 doesn't fit into there, 3 doesn't fit into there, 4 doesn't fit into there. Okay? So there are many times really big numbers, 43, right? The only numbers that fit into 43 are 1 and 43. You can't say 3 fits into 43, does 7 fit into 43, does 2 fit into 43, does 12 fit into 43. Make sense? Adding mixed numbers. How do you add those? Because now you have not just fractions, but you have those whole numbers as well. Well, number 1, add the fractions, just like we did in the past, right? Make sure all the bottoms are the same, and then add them. And then, if you have a mixed number, convert it to, if you have an improper fraction, then you want to convert that to a mixed number, and then you just want to add the whole numbers. Okay? So for example, we have 4 and 7 over 20. Okay? And we want to add that to 6 and 3 over 5, and we want to add that to 7 and 1 over 4. Okay? So the first thing we want to do is we want to add the fractions. But to add the fractions, we have to make the 20, the 5, and the 4 to equal the same. Because right now we have 3 different numbers at the bottom. Well, we realized we can fit all of them we can fit 4, 5, and 20 into 20. So 7 over 20 is equal to 7 over 20. 3 over 5 is equal to 12 over 20. 1 over 4 is equal to 5 over 20. Okay? So now they're all fractions. They're all still proper fractions, right? It's not like we have a 22 over 20 or anything improper. And so now we add all of those, 7, 12, and 5. Well, that is equal to 24 over 20. Now we have an improper fraction. So now we're going to convert that to a mixed fraction. So 24 over 20 is equal to 1 and 4 over 20. Okay? Step 2, now we want to add the whole numbers. So we want to say 4 plus 6 plus 7 plus 1, right? Because we got that new whole number from all the fractions. So 4 plus 6 plus 7 is equal to 17, but we want to add that 1, which makes it 18, and then we just bring down the 4 over 20. But here's the thing. 4 over 20 can be simplified. You can divide the top by 4, and you can divide the bottom by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. So after all of that, you see 4 and 7/20, 6 and 3/5, and 7 and 1/4 is equal to 18 and 1/5. That's a long process, but that's what it equals. So how do you subtract? Well, it's the very same thing. Make sure that your numbers are all the same at the bottom, and then you just treat it. 9 minus 1 is equal to 8. Okay? And then, of course, when you get the answer, you want to make sure that it's in this reduced and most simple form. So 8 over 10, you can fit 2 in the 8, and you can fit 2 into the 10, and so you can make it 4 over 5. How do you subtract unlike terms? Again, make sure you convert it to the LCD so that you can make sure that your numbers at the bottom are the same. And then what do? You just divide the numbers as the top numbers as if you would do a normal subtraction in regular math. And 40 minus 2 is equal to 38. And 38 over 64 can be simplified, can be reduced to 19 over 32. What about mixed numbers? Okay, I'm not going to spend time on this because I want to spend time on the next one. But if we were to have, you want to convert them again to whole numbers, make sure you find the LCD first, and then you subtract the whole numbers, and then you reduce it to the terms. So 1 over 2 is equal to 4 over 8, and 3 over 8 is going to stay the same as 3 over 8. So 4 over 8 minus 3 over 8 is equal to 1 over 8. And then don't forget you have the 6, that since there's no 1, there's no whole number in 3 over 8, you don't have to subtract the whole number, so you just bring the 6 down exactly as it is. Okay? But what if there are whole numbers in the bottom ones, and what if it doesn't work out so exactly, which probably it won't? Well, you want to make sure that you subtract your the bottom numbers. So let's see, for example, what would that look like? 1 over 2 divided by 3 and 1/2 minus 1 and 3/4. Okay? So 1/2 is equal to 2 over 4. But how can you say 2 minus 3? Because you're not allowed to put negative numbers. Okay? So this is where you borrow from the whole. Now if you take a whole and convert it to fractions, you're going to add 4, right? Because we took a whole and we made it 4 out of 4. So now we add that 4 to the 2 and we get 6 over 4. But we took away that whole number, so the 3 becomes 2. So now it's 2 and 6 over 4 minus 1 and 3 over 4. So now we say 6 minus 3, which is equal to 3 over 4, and 2 minus 1, which is 1. And then, of course, don't forget to reduce it if you need to. And then if you want to multiply proper fractions, you want to make sure that you multiply the top numbers and multiply the bottom numbers and then simplify, and you will be fine. Reduce it to numbers and you'll be fine. How do you multiply mixed numbers? Okay? Well, first of all, you want to convert the mixed numbers to improper fractions, and then continue as before. Multiply the top, multiply the bottom, and then reduce to not only the lowest terms, but then convert it back to the mixed number. What about dividing? This one's really easy because multiplying is the easiest of them all, right? So if you say 1 over 8 divided by 2 over 3, just turn over that 2 over 3, turn it over to 3 over 2, and then multiply it. So if you do the opposite of the number, it's called a reciprocal, right? So you're going to turn it all the way around, and then you can just multiply it. Because you turned it around, the opposite of dividing is multiplying. And you just multiply and reduce like normal. And how do you divide mixed numbers? Same thing, just have the first extra step of converting it all to improper fractions. And then, so if you have this times this, number 1 times number 2, convert number 2 to the reciprocal. The number on the top goes to the bottom, the number on the bottom goes to the top, and multiply it as normal, and then reduce, and then put it back to the mixed number. Okay, that was it. That was a lot of information. I didn't want to get bogged down because you know, I feel like I covered the information enough that you're going to be able to do your homework assignment. But if you don't, and if you need some help, please let me know. I can tutor you. I don't want you to think this is an empty offer. I got one student say, well, you know, you hear a lot of people say, just reach to me, and they don't really mean it. Well, I do. I really do. If you don't know math, it's going to be horrible as you get later on in the classes. So reach out to me. Again, these are due by midnight on Thursday, and I look forward to seeing you guys at the live lecture on Thursday night at 8 p.m. Hope to have your homework attended. We'll do some practice questions so we're all on the same page. Other than that, we are good to go. Thank you very much for watching, and have a great week.